Okay, so that means that ax is nothing but the projection of this vector a to the x component. In the similar way, ay, this ay will be the projection of this a vector to the y component, and similarly for the z. Now, how do we add two vector if this vector will be expanded in the component form? So let's see this a plus b. If we expand the a as a ax, x cap, ay, y cap, and z. So we are just taking only the two component. Okay. Plus, in similar way, we will expand the b similarly. By sorry, this is bx x cap plus by y cap. So the rule to add this two vector will write the ax with bx and this a cap, ay with by, and this y cap. So what we does, so the summation of two vector a and b will give a c vector. So we are expanding the a in x cap and y cap direction. In a similar way, we are expanding the b in the x cap and y cap direction. So the result c should also be expanded in the x cap direction and the y cap direction. How we can do this? Well, we can take this ax and this ax and this bx and sum together and common out this x cap direction. In the similar way, we will do this with the y cap direction. If the z component will also exist, then we can similarly add for the z add the z component of these two vector, and will write this z cap in the at the end. So this is the way we will add two vector if it is expanded in the component form. So how do we multiply with the scalar? Okay, so this is the addition, the first thing. The second is the multiplication with the scalar. So let's write this is a multiplication with the scalar. Okay, so a into vector a will be, so a into ax x cap, ay y cap. We are not taking the z component, and it will it will take more effort to write and solve for all three components. So I am taking for the two component, and the same thing apply with the z as well. So we multiply a with ax and then x cap. Okay, so this is the final vector. Let's say a times a will be a c vector, so the cx will be this product, and cy will be a times ay y cap. Okay, so the component will be scaled up by this factor a. Okay, there is no change in it change in the direction of the final vector. So this is this second rule, the second operation. The third operation that we did with our vector was the dot product. So I'm sorry. So let's say we take the dot product of a with itself a. So how, or let's assume first of all we'll take the general a dot b. So what it tells, let's expand ax into x cap plus ay into y cap. Okay, dot with bx into x cap plus by into y cap. Okay, so what we have to do is to multiply. Okay, so the ax bx, okay, we have and okay, so and will x dot x, and then we have ax by x dot y. We will have ay y ay bx y dot y cap, and then we have ay by y dot y. Okay, so this will give to 1 because these two are the unit vector and their dot product will be let's see this. If we have x dot x is nothing but the magnitude of x, magnitude of another x, cos of theta, and here the theta will be 0 degree because this x and x vector, same vector, will lie on each other. So this 2 vector will no it's not, I'm sorry, it will not give 0, it will give 1. Okay, because these 2 vector will lie on each other. So and this magnitude is just 1, so the overall value will be 1. X dot y will be 0 because x and y are perpendicular to each other, as we have seen above. This will also be 1 and this is going to be 0, so the final will be ax bx plus ay by. And if we have one extra term like for say az bz will be added if we have one more component. Okay, so this is a dot b. And what about the a dot a? If we are taking the same vector and taking the dot product of them with each other, then we have ax into ax plus bx ax ay into ay, which is nothing but ax square plus ay square, and this is nothing but the square of the magnitude of vector a. So that means the dot product of the same vector, dot product of the vector with itself will give the square of the magnitude of that vector. Okay, so now let's come to the third operation of the vector, which is the cross product. So so we have vector a cross b. So what we will get? So we can write it in the determinant form x cap, y cap and z cap. Here we can write ax, ay, az. Here we can write bx, by and bz. So the final result will be something like this: x cap, right, ay bz minus az by minus of y ax bz minus az bx plus this z cap ax by minus ay bx. This is the final vector, which is maybe vector c, and this is the cx, the x component of this vector, final vector c. This is the cy and this is the cz.